topic is relation between drift velocity and current. Consider a metallic conductor. Let L be the length of the metallic conductor and A be the area of cross section. The metallic conductor consists of free electrons. If we connect the metallic conductor to a potential, always the electrons move towards the positive end. The reason is the electrons are negatively charged. So first we have to calculate the volume of the conductor. Volume of the metallic conductor is area into length. The total number of electrons in the conductor is N into A into L. The next we have to calculate the total charge. Total charge Q is equal to N A L E. And the next we have to calculate the time taken by the electrons to move from the terminal Y to X. To calculate the time, we know the basic equation. Speed is equal to distance by time taken. From this relation we can write time is equal to distance by speed. Therefore, the distance travelled by the electrons from the terminal Y to X, which is always equal to L. And here the speed of the electron is same as the drift speed. The drift speed which is represented by the letter Vd. And our aim is we have to calculate the value of current. So you know the equation. Current is equal to charge by time. So you can substitute the value of charge. You get N A L E. And time, you can substitute the value L the whole divided by D. The same equation we can write N A L E V D the whole divided by, here it is L. Therefore, the current can be written as N into A into E into Vd. This is the relation connecting current and drift velocity.
If you found this video helpful, please like, share and subscribe to the channel. See you next class.